Hello and welcome back to yet another webinar in this series of MI2, Machine Intelligence on Modern Infrastructure. My name is Janakiram. I'm going to be the presenter for this session. Before we get started, let me make sure the AV experience is good. So I'm going to bring up a poll just to make sure that you're able to see the screen and listen to the audio. So let me know if you have any problems with the audio or the visuals. Excellent. Looks like we are set. All right. So what is MI2? So MI2 webinars primarily focus on the emerging technologies in the space of machine intelligence and modern infrastructure. Every alternate week, I bring you informative and insightful sessions covering a variety of technologies, particularly in the space of machine learning and artificial intelligence, IoT and edge computing, containers and microservices. While containers and microservices form the infrastructure, ML and AI combined with IoT deliver the machine intelligence. So this is the convergence of these two technologies where we explore some of the emerging trends, some of the new products, and exciting emerging technologies that actually redefine how we are going to deal with the current use cases, scenarios, and the upcoming business case studies. So let's get started. So today's session is all about AWS IoT Greengrass, and I've been working on this for a couple of years, and I'm pretty excited to bring you the big picture of AWS IoT Greengrass. And I have a very interesting demo. It's a live demo. I'm going to switch to my screen. If you actually see my camera feed, you notice that there are some devices. So it's going to be an interesting live demo. I'm keeping my fingers crossed, but I'm very sure if everything goes the way I'm expecting, this is going to be a very useful and interesting session for you. So that's the agenda where I'm going to walk you through the details of AWS IoT Greengrass, followed by a very comprehensive demo. But before we go further, like every time, let me bring up another quick poll. So if you use edge computing, what is your preferred platform? And if you are not using any of the listed technologies, it's absolutely fine. Feel free to choose the last option. And this is a very, very new, nascent, emerging technology. So I don't expect you to be very familiar. As expected, most of you are telling me that you haven't used any edge computing platform, but 10% of you are actually using Azure IoT Edge. All right, that does give me a sense of where you are. So looks like most of you are new to AWS IoT Greengrass. So let me walk you through the details. So when we look at the waves of innovation, it all started with cloud, which gave us abundant storage and compute, and that changed the game. So that led to the cloud providers like Microsoft, Amazon, and Google offering us Internet of Things as a platform. So in the last 4 years, IoT has become one of the key drivers of the public cloud. A lot of manufacturing, automobile, healthcare, financial, and many other enterprises are actually connecting their sensors and a variety of devices to the cloud to primarily store the data that is coming out of the sensors and the existing devices, and also to process them, analyze them, and then apply machine learning to find interesting trends and to perform predictive analytics. So IoT has been truly a game changer when it came to cloud. But once customers started using IoT, they realized that not everything needs to be in the cloud for various reasons. It could be because of privacy. You don't want to send all the data. It could be because of the bandwidth cost. You don't want to ingest every data point all the way to the cloud. The third thing is you may want to have very low latency turnaround between your devices and decision making. If everything is running in the cloud, the round trip is going to take much longer, and that's going to defy the purpose. So that's when edge computing came in as the middle layer between the cloud and the devices. And with the rise of AI, edge is becoming the destination for running machine learning and artificial intelligence models. So machine learning models are trained in the public cloud and are deployed at the edge to perform inferencing or to make predictive analytics and decision making. So These are the trends that took place in the last 4 to 5 years. Cloud to IoT to edge, and now the convergence of IoT and AI right at the edge. So if you look at the big picture of IoT platforms, it doesn't matter whether you're using Azure IoT or AWS IoT or even a homegrown IoT platform, they all have certain similarities and certain key building blocks. So there are devices, and these devices are the sensors that send a lot of data, or they could be actuators like bulbs, switches, relays, and so on. Now, most likely, these devices are connected to a local gateway, which is also called as the edge computing layer, and that layer is connected to the public cloud. And on the public cloud side, we have two touch points for the devices and edge. The first one is device registry, which is acting as the repository of all the devices that are registered with the platform. Data ingestion, where high velocity, high throughput data is ingested very frequently at a very frequent time window, and that is going to go through a message routing policy, which will define how this data is going to be split between real-time processing and batch processing, and how the raw data is stored, and how the process data is going to be stored. And that's where we have the batch processing layer, which is also called as cold path analytics, and stream analytics layer, which is also called as hot path analytics. And then we have storage and databases for persisting the raw sensor data and also the process sensor data. And that data can be fed to machine learning to find insights and to perform predictive maintenance and predictive analytics on the inbound data. Now, ultimately, all of this is fed to a business intelligence platform where there are dashboards and a variety of visualizations to understand how your devices are functioning. So this is the big picture. Now, translating this to AWS IoT. So AWS IoT started in 2015 with Amazon acquiring a company called Telemetry. And what started as a very simple IoT device management and M2M layer in the cloud has now been expanded significantly. Today, when you look at AWS IoT, there are three different layers, three different pillars. The first one is, of course, the devices, that is the things which actually sense and act. And there Amazon has a couple of products. The first one is Amazon FreeRTOS, which is a real-time operating system that can run on top of a microcontroller with 64 KB of memory or more. And then they have AWS Greengrass, which is the edge computing software that is going to be interfacing with the local devices, running either Amazon FreeRTOS or the AWS IoT Device SDK. So that's what runs on premises, at the field, on the devices side. And when it comes to cloud, there are two important aspects. The first one is AWS IoT Core. And as the name suggests, it is the core building block of the AWS IoT platform. It is responsible for registering the devices, so it acts as the device registry. It also exposes endpoints for MQTT, WebSockets, and HTTP for the devices to talk to each other and to talk to the cloud. And it is also the touch point for applications that want to control the devices running on-prem or in the field. So AWS IoT Core acts as an interface between the applications. For example, a mobile app that is talking to a device will have to go through the AWS IoT Core, and similarly, a device that is sending sensor data to the cloud will also have to go through IoT Core. So that is the gateway, that is the cloud gateway, that is the cloud device registry, that is the machine-to-machine M2M endpoint, which is called as AWS IoT Core. And then there is IoT device management, which supports bulk onboarding of devices, because registering one device at a time in industrial use cases is not feasible. So it supports bulk onboarding and also has properties like over-the-air software updates, maintenance, and performing bulk jobs, operations, and so on. So think of it as the device management at scale. And then there are a couple of more services. For example, AWS IoT Device Defender is all about security. It figures out if there is a drift between the preferred configuration and the policy and what is currently running, and it automatically raises alerts. It also maintains a highly secure footprint of all the devices, and if there is any anomaly, it is going to raise an alert. So that is the Fleet Audit and Protection Service, which is the IoT Device Defender. And finally, there is an analytics solution, which is the AWS IoT Analytics. And this service is responsible for analyzing the trends and visualizing, and from there feeding to more powerful systems like QuickSight or Redshift and so on. So that is the entire suite of AWS IoT services. And obviously, we are going to focus more on Greengrass. But before that, it's important for us to understand AWS IoT Core. So let's take a closer look at that. So as I mentioned, AWS IoT Core is all about connecting devices to the cloud. The moment you bring in your first device that is going to be connected to AWS, you need to talk to AWS IoT Core. And the workflow is pretty straightforward. You need to register your device with AWS IoT Core, and that is going to act as the digital identity of your device. The moment you register a device or a thing, AWS IoT Core will give you a set of certificates that act as the credentials for the device, and you grab those certificates, X.509 certificate infrastructure, the PKI based one, and you embed those certificates along with the AWS IoT device SDK within the device. It could be running a microcontroller, it could be running a single board machine, single board computer, it could be a slightly more powerful machine that can talk to a Modbus or CAN bus internally, or it could be even an automobile device like a car. You can actually register anything. The moment you register, you receive a set of credentials, and you're going to embed those credentials in the device. And the moment the device has those credentials and it connects to the cloud, it gets authenticated, authorized, and it shows up in the device registry. And after that, it can send messages to the cloud, and it can receive commands from the cloud. So that is the basic workflow. And when you zoom into AWS IoT Core, the first one is all about authentication and authorization. The second one is device gateway, which is the cloud endpoint for talking to the IoT core. Message broker, which is based on, as I mentioned, MQTT, WebSockets, and HTTP. So this is meant for publishing and subscribing messages or feeding data from the device to the cloud using HTTP or WebSockets. But it is predominantly used for two-way communication between devices and the cloud to send some metadata or telemetry and to receive some settings or commands. There is a rules engine, which is obviously going to decide how the messages will flow into rest of the system. And the rules engine is ANSI SQL compliant. So you can actually write simple select statements that will filter the messages and apply a rule. And the outcome of this rule can be hooked to a Lambda function, which is going to take further action. And because the devices may not be available all the time, there is also a concept called as a device shadow. And the device shadow is the digital twin, the digital identity of the physical device that is running in your deployment. And all the changes that are made to the device will first get applied to the device shadow, and then it gets propagated all the way to the device. And similarly, every time the device state changes, it automatically gets synchronized with the device shadow. So device shadow acts as the buffer between the desired state and the current state. And the job of the platform, the AWS IoT Core, is to make sure that at any given point of time, the desired configuration is matching with the current configuration. So that's how you'll use device shadow as a buffer to maintain the desired configuration, the desired state, and also to query the current state. And of course, device registry is like a huge database. It's a repository. It's like LDAP, but meant for the devices or things that you connect to AWS IoT. So these are the core building blocks. Now, the reason why I wanted to spend time walking you through AWS IoT Core is Greengrass is modeled around this. So the job of Greengrass is to bring AWS IoT Core all the way to the edge. So now to put things in perspective, this is how you actually use multiple building blocks of AWS IoT Core. So the device SDK, which is supported in a variety of languages, all the way from Node.js to Python to C to Java. So you actually use that SDK to connect your device to the cloud. The first touch point is all about authentication and authorization. and from there it goes to device gateway, which is meant for communication, and from gateway it goes to a rules engine and also to the device shadow, which is going to maintain a replica of the state. And all the applications talk to the device shadow. They never talk to the device directly. And the rules engine is responsible for extending the IoT platform to rest of AWS services like DynamoDB or Neptune or Redshift, EMR, SageMaker, and so on, and even to third-party services like Twilio, SendGrid, and so on. And all of this is exposed via AWS IoT API. So the device SDK is very different from IoT API. So IoT API is accessible from Boto or any of your favorite languages, and you can provision all these resources, while the device SDK is meant exclusively to connect devices to the cloud. Now, coming to what is edge computing. So we went through an elevator pitch and a very quick overview of IoT in the cloud, and specifically AWS IoT Core. So what is edge computing? So edge computing makes the cloud truly distributed, because in IoT, industrial IoT scenarios, not everything can run in the cloud. As I mentioned, there are a lot of concerns and a lot of legitimate use cases to bring cloud functionality of cloud to on-prem, and three factors: latency, privacy and confidentiality, and the bandwidth. Those are the three factors that decide or that influence the decision of going for an edge computing investment. So it moves core cloud services closer to the origin of data. So in IoT, origin of data is sensors and actuators. So edge brings some of these cloud services very close to the devices. Edge mimics the public cloud platform. More or less, it exposes similar API. So most of the devices that are designed to talk to the cloud will continue to work with minimal changes, which means your devices don't know whether they're talking to a local edge computing layer or to the cloud layer, because the APIs are exactly the same. And not only the APIs, but even certain compute, storage, and stream analytics databases are also brought down to the edge, which are highly compatible with their cloud counterparts. It reduces the latency by avoiding the round trip. So the edge acts as a filter, as the middleware, sitting right in between the devices and the public cloud. So what is AWS Greengrass? So AWS Greengrass extends AWS IoT to your devices, so they can act locally, and the data that they generate are is filtered before it is sent to the cloud. So think of Greengrass as a local extension of AWS IoT Core. Just like AWS IoT Core, there is a message broker built into Greengrass, so devices can continue to talk to each other. And just like the AWS IoT Core and rest of AWS, there is a compute layer which is based on Lambda, and you can actually write functions that are run locally, and they are triggered when a specific condition is met. That is what is the local triggers. And these triggers will actually fire Lambda functions that perform an action. And we're going to see a live demo of this. You can also have the data and state synchronized with the cloud, again, thanks to local device shadows and the cloud device shadow. So if you are updating something locally, it first gets written to the device shadow running on the edge, and then it eventually gets synchronized back with the cloud. There are a lot of connectors and protocol adapters, for example, to talk to legacy protocols like OPC, UA, Modbus, CAN bus, or even very proprietary protocols. You can implement all of them using the connectors and custom Lambda functions. Unlike the cloud that doesn't have access to your on-prem resources, Greengrass does give you local resource access. For example, you want to talk to a local database which already has some metadata or some material asset tracking information. You can query that directly. You can also talk to the file system. You can talk to databases. You can literally talk to anything that is accessible within the network that Greengrass core is running on. And more importantly, the most recent feature is the ability to run machine learning inferencing on the edge. And this is big. This is one of the key drivers, because there are three aspects when it comes to IoT. So the first one is the learning part, which is happening in the cloud. So learn is going to be done on the cloud, where you train machine learning models. And in Amazon's case, it is going to be SageMaker. Then you have decision making, which is decide, and that takes place at the edge. And that's where fully trained machine learning models are used, and they make decisions on behalf of the cloud. And then there is an action layer, or the action phase, that is directly done by the devices. For example, a machine learning model trained in the cloud to find an anomaly is deployed on the edge, and because an anomaly is found with a very critical device, the machine learning model decides that one of the other equipments need to be shut down. And that decision will result in an action where an actuator or a relay or another interface physically shuts down a malicious or a vulnerable machine to avoid any eventuality or any fatalities. So that is the learn, decide, and act cycle that happens with the cloud, edge, and devices. So that is the continuum that customers are preferring, and Greengrass enables it by sitting right at the middle and performing the decision part of it by running local ML inferencing. So to take a closer look at AWS IoT Greengrass, so it all starts by creating what is called as a Greengrass group. And a Greengrass group acts like a logical boundary. If you have a common use case, for example, you have a bunch of elevators that are working together or in tandem in a building, you might want to create an AWS IoT Greengrass group that represents all the elevators plus an edge computing device responsible for talking to all the elevators. So you bring in the edge device plus all the elevators that are acting as devices into one group. And this group is a logical boundary, and you can apply common policies and logically manage and maintain all the devices plus the edge device that belongs to this group. Now, every group has what is called as the Greengrass core, and Greengrass core is nothing but yet another device. The only difference between a normal device and a Greengrass core device is that the core device actually runs the Greengrass runtime, and the Greengrass runtime is nothing but a daemon. It's a Linux or a Windows process that actually runs within the operating system. It's actually, if you're running on Windows, you could actually use a Docker container, but technically it is just a process. It's a runtime that runs within a powerful device, maybe capable of running a Docker container or running a slightly powerful environment. And that's the reason why a Greengrass core device is considered to be like an ARM device or an x86 device running Linux, and it is it has at least 1 GB of RAM and running a decent processor like an Intel Atom or an ARM v7. So that is what differentiates an IoT Greengrass core device from rest of the devices. Rest of the devices could be just microcontrollers that may not be capable of running the Greengrass runtime. Now, within the Greengrass core, we are going to run Lambda functions, and these Lambda functions act as the glue, and they are the coordinators, they are the connectors that bring everything together. For example, when an elevator sends some alert, some malicious data, some anomaly, it is the Lambda that actually figures that out and triggers an action, which could be like sending a notification or an alert to one of the supervisors responsible for that floor. So how does the supervisor know when the lift is malfunctioning? Well, the lift will send some data point as the MQTT feed to AWS Greengrass core, and that is forwarded to a Lambda function, and the Lambda function uses an API to basically push a notification to the mobile phone of the supervisor. So that is the role of Lambda. Similarly, it can also do lookups. For example, you want to find out the number of the service engineer responsible for that elevator, or you want to find out more information about the elevator and automatically send out a trouble ticket to the elevator company. Lambda function can do all of that. by looking up that information in an asset tracking system and automatically generating an email and sending it out via SendGrid. You see how Lambda works in the context of Greengrass and takes actions. Then there are subscriptions, and subscriptions are traffic rules. They are the routing rules. So by default, devices or Lambda functions cannot talk to each other. Unless you have everything fed to the cloud, you cannot really gain access to individual MQTT topics and various other internal communication channels. So to facilitate that, you create a routing rule that says, okay, the elevator is going to publish, it is acting as the sender, it is going to publish on this topic, and the receiver is the Lambda function. And then you will create another rule that says, okay, here is the Lambda function that is going to write into another MQTT topic, and it now talks to AWS IoT on the cloud, because from there you actually run additional stuff. So every routing rule has a sender, has a receiver, and has a topic that is authorized for them to talk to each other. So it's a very simple rule that connects a publisher to the subscriber, or to the sender to the recipient. And finally, there is a device definition, which is going to help us manage the local device shadows. So those are the core elements of AWS IoT Greengrass. Now, with the background set, I want to really show you a very interesting demo. This is a real world use case, and I spent a lot of time building this end-to-end demo. So what are we going to build? So I'm going to walk you through a scenario. So we have a smart camera that is deployed at a toll gate. And this camera is responsible for detecting a variety of vehicle types. And it automatically charges the driver with an appropriate toll fee. For example, when a commercial vehicle, a heavy vehicle passes through the toll gate, the smart camera automatically detects and calls an API to deduct from the prepaid card or to automatically charge their account. And it increments the count and updates a variety of systems. Now, because I cannot demonstrate this entire workflow, I wanted to show you changing the color of a smart bulb depending on the vehicle type. While it is possible to build the entire workflow, I wanted to show you something visual. So I'm taking the help of a smart bulb that changes the color when a vehicle type is different. For example, when the smart camera detects a car, the bulb glows green, and when it is bus, it glows blue, and when it is not an identified vehicle or it is not a vehicle at all, it just switches off. So that is the use case. So the idea is when we flash a vehicle in front of the smart camera, the bulb glows and the color depends on the vehicle type. Now coming to the topology, there are two Raspberry Pis. So one Raspberry Pi is responsible for controlling the camera. That's where the machine learning model runs, which is based on object detection. And then there is another Raspberry Pi 0W. It's a tiny device, and that is responsible for controlling the bulb, the smart bulb. And both these Raspberry Pis are connected to a Greengrass core. And this Greengrass core is actually another Raspberry Pi, but this is not a Raspberry Pi 0. It's a Raspberry Pi Model 3, Raspberry Pi 3 Model B+, which means it's more powerful, it has more memory, better CPU, and is capable of running Greengrass core runtime. And this Greengrass core runtime talks to the cloud, which is AWS IoT Core. So if you actually see, this is exactly how I've been explaining the role of an edge computing device. So on the left-hand side, we have the camera and bulb that are the devices. Camera is generating some data. Think of it as a sensor, and the sensor is going to detect the object type and simply sends this information. And instead of sending it all the way to the cloud, which is AWS IoT Core, we introduce the middleware, which is Greengrass Core, and it is going to immediately figure out what action to take. And here, the action it takes is to send a different command to the bulb, which is changing the color or switching off the bulb when there is no vehicle. And the best thing is, even when AWS IoT Core is inaccessible, that means in a highway, in a freeway, not every time you may get connectivity. So when Greengrass Core loses connection with the cloud, it still works. We don't need to rely on the cloud. So that is the beauty of the edge. So it's time for me to show you a walkthrough. So I'm 30 minutes into this session, spot on time, and remaining 30 minutes, I'm going to walk you through the entire demo. So we are going to manage a smart camera and a smart bulb with Greengrass. So let me walk you through the scenario. All right. So here we are. This is AWS IoT landing page on the console, and here you notice that there are give me a second, I want to get rid of some unwanted windows. Okay, so it all starts with this. This is the home page of AWS IoT Core, and if you go to Greengrass, you'll actually notice that it prompts you to create a group. So the very first step in dealing with Greengrass is to create a group. So you can create a group by clicking on this button, and once you create the group, it's going to define a core. Now, one important thing is you cannot have an AWS Greengrass group, IoT Greengrass group, without a core. So core is really the front and center of the Greengrass group. So as you create a group, you'll also end up creating a core, and this core is just a device but has additional capability to run the Greengrass runtime. And once you create a core, then the next step is to onboard devices. So the devices that are already connected to AWS IoT or the devices that you are creating for the first time can be very quickly onboarded onto Greengrass. So that is the initial workflow. Create a group, create a core, and then onboard devices. So now it's time for me to actually show you what we have here. So this is the smart camera, and this camera is actually pretty smart. The reason why I call this as a smart camera is, instead of running machine learning models and training them, this camera actually has an Intel Movidius VPU, which is the vision processing unit, and it automatically runs machine learning models. I don't need to really train and deploy. It comes with some pre-trained models like face recognition, object detection, image classification, and a variety of other models that are preloaded into this camera. So we don't need to run or train any models. So this is connected to one of my Raspberry Pi Zero devices. So if you see, it's a pretty simple topology. This is the camera connected to a Raspberry Pi Zero W, and this Raspberry Pi Zero W is acting as the driver for the camera, because this camera doesn't have compute. It cannot really send data, or it cannot talk to IoT endpoints. This is just a camera. The only difference between a dumb camera and the smart camera is every frame that the camera passes is going to come out of a TensorFlow model, and this TensorFlow model is what you choose, whether you want to recognize faces, whether you want to recognize objects, or you want to perform image classification is what you decide. And this camera simply feeds that information to the Raspberry Pi, and this Raspberry Pi uses that to process it further. So instead of connecting a temperature sensor, I'm actually connecting a smart camera, which is acting as a sensor, and this sensor, for all practical purposes, can identify objects, and those objects could also be buses, cars, vehicles, and so on. So this is acting as one of my IoT devices, and this is running the IoT device SDK. Now you see a bulb here. This is a smart bulb. This is a Philips Hue smart bulb. I don't need to be powered, so I can actually get rid of this. So this is a portable smart bulb, and this smart bulb is connected to another Raspberry Pi, and this is acting as a driver, because I connect control this bulb directly because it uses a protocol called Z-Wave. I cannot talk to this bulb directly. So what I do is I actually connect the bulb to another Raspberry Pi, and this Raspberry Pi doesn't have anything connected to it except the power. And this is responsible for accepting a command and then sending it in a language that my bulb understands. So two devices, the smart bulb and the smart camera, 2 Raspberry Pis acting as the compute drivers for these two. And what you don't see in this frame is another Raspberry Pi that is actually acting as the edge device, and that is not in the frame. It is running in my lab. I need not show that to you because it is just a Raspberry Pi, and I'm going to SSH into it and show you the software component, but that is the edge. So coming back to the portal, now let me show you the group. So I've gone ahead and created a group. Doing this on the fly is going to take a lot of time, so I didn't want to do that. So I have already created the entire demo, but I'll walk you through it. So we have this group called Mi2 demo, and this Mi2 demo has one core. So Mi2 demo core, and this is the Raspberry Pi model 3B plus that is actually running the runtime. That is what I was mentioning. And apart from the core, there are 2 devices, and as you expect, these 2 devices, bulb, that is a smart bulb, and the camera. So these 2 are registered as devices and also added to the group, which is called the Mi2 demo. Now let's take a look at what's running inside. So let me switch to the command line and SSH into my Greengrass core. So the Greengrass core is actually a Raspberry Pi. So if you look at this, this is running an ARM v7, and it's a Raspberry Pi 3. Now within this, I have gone ahead and set up the Greengrass runtime. This is pretty straightforward. You just need to download a tar file, unzip it, untar it, and then create a certificate and populate your certificates in this directory. And after that, you create what is called as the config.json. So the config.json is responsible for registering your Greengrass core with the cloud. So here you'll actually mention that here is the root CA, here is the private key, here is the certificate, and this is the thing ARN, the Amazon resource name, and the IoT host. I'm currently talking to Tokyo endpoint. So that's it. These certificates are responsible for authenticating and authorizing our IoT Greengrass core device with the cloud. That is the first step. Now, once this is done, once I basically configure my Greengrass, what it actually does is it runs as a daemon. So here in this directory, you notice that there is something called Greengrass D, and this is the daemon that I'm actually running. So if you look at my current running processes, you should be able to see Greengrass. Okay, let me make sure it is okay. I need to be sudo. So this is now restarting my core. Okay, so it is running with a PID of 9665. This is perfect. So now this actually confirms that Greengrass core is up and running. That's perfect. So now that we have the core running, the next thing is to take a look at the camera and the bulb. So let me SSH into the camera. So again, the camera is nothing but another Raspberry Pi 0, which is acting as the front end. So I SSH into it, and I'll give you a live demo of the object detection. So within SmartCam, I have a standalone application called tol.py. Now, when I actually show you how this works, so here is my camera. In a second, this is going to load the entire camera and all the machine learning models. It's going to take a few seconds. Let's give it some time. There we go. So now you actually notice that the blue LED is blinking. That's an indication that a model is now active. Okay, so with this running, what I'm going to do is to place a car in front of the frame. So as soon as I place a car and switch to the command window, you notice that my code is able to detect that it is a car. Perfect, right? Now I'm going to replace this with a bus. Now, as soon as I put a bus inside the frame, there we go. So now the camera is able to detect that it is a bus. This is exactly what I wanted. Now, this inference is what I'm going to send to Greengrass core. So let's actually look at the bulb. So the bulb is, again, it's a smart bulb. I can control this from code. I can control this from my mobile app. So we can actually see this in action in a minute. But let's go back to the portal and see how we actually configure this. So now it's all clear. Greengrass core is running in one of the edge computing devices, which is another Raspberry Pi. We have two devices, both of them are functioning. And now let's take a look at the next important thing, which is the subscriptions. So here I have a subscription. Basically IoT cloud sends the or rather the camera sends the information to IoT cloud, and from there we send it to a Lambda function, and the Lambda function sends it back to the bulb. So how does this work? Well, I think it all makes sense when we actually see a live demo. So let me SSH into the bulb as well. So now what I'm going to do is to launch my code that is responsible for controlling the bulb. This is running on the Raspberry Pi. So this is going to take a couple of seconds to start. And what it actually does is it uses the AWS IoT device SDK and waits for the MQTT topic to send some commands. So we'll leave this as it is. And then I'm going to, currently there is no vehicle in front of the toll gate, in front of the smart camera. Now what we'll do is run this command called cam.py, Python 3 cam.py, and this loads the camera models for inferencing and also uses the output of that to send to the cloud. So now we actually see that there is no object. The object feed is none. Now what I'm going to do is, again, place the car, and there we go. Perfect. Even before I showed you my command line interface, it actually started glowing. So now the object is detected as car, and immediately the bulb has become green. So now what I'm going to do is to take off the car from the frame, in front of the camera, and the bulb is off. Perfect, right? And let's actually place the there we go. So now the bulb is glowing blue, and I'm not surprised, right? Because the camera has detected it as a buzz, and now the entire workflow has kicked in. So that is the beauty of AWS Greengrass core. Now, the best thing is I don't need to be connected. I don't want to take the risk of disconnecting my devices at this point, but I have tested this. It works offline, which means this entire setup of Greengrass core and devices can be completely offline, and it still works. So how does this magic happen? Well, let me show you the entire workflow. So I'm going to take off the object from this. Now, let me show you the code for each of the devices. First thing is I want you to understand how the camera works. So camera is actually called as Horn Sanjam. If you are interested, I have written about it. I have published a couple of tutorials and also posted on YouTube. Take a look at it. So this comes with a class called object detector. Fantastic. And you don't need to train a model. You don't need to deploy it with TensorFlow Lite, or you don't need to do anything. Just create this class called object detector, and after that you tell whether it is coming from the webcam or the built-in camera or a static image, and after that you put that in a loop, and every time you invoke net.run with the image. And by the way, the image is a camera grab. It's a feed coming from camera, one frame at a time, and then I check if there is any object detected. If it is an object that is detected, I basically access it using this list. Result of 1 contains the actual label, and I simply print that label. And if you are connected to a monitor, the Raspberry Pi is connected to a monitor, you can also visualize the object. So it draws a bounding box and all of that. So that's what is cv2.im show, and this runs in a loop. So when I hit Control C, I close the model net.quit. So now this is how a Horn Sanjam smart camera works. Pretty smart, very few lines of code. I have never imagined that you could technically write like 20 lines of code and get away with object detection. That too offline model. We are not calling a cognitive API running somewhere in Google or Microsoft or IBM. This is running locally. So now what I've done is I've taken this code and merged that with the AWS IoT device SDK. So here we are using the AWS device SDK and we are using Python. So here this is the device identity, the root CA, the certificate, the private key, the host, which is the MQTT endpoint that we need to talk to, and I'm giving the client ID as cam1, and it is going to publish to a topic called camera/infer. This is an MQTT topic, and then I open the object detector, and after that I use the standard plumbing for MQTT. So this is all about creating and instantiating the MQTT client for the cam. And once I call cam MQTT client.connect, it establishes connection with Greengrass. And then I put the same while loop, but instead of printing it on the monitor on the std out, I'm actually publishing that to an MQTT topic. Now this MQTT topic shows up on the cloud. So how does that work? Let me take you back to AWS console, and here if I actually go to subscribe to a topic, and if I subscribe to a topic called camera/infer, you will see that it's currently showing the same camera feed. I have placed a car, and now you'll see that it is showing car. That means the Raspberry Pi connected to the camera is publishing constantly to this MQTT topic. So when I take off the car from the frame, it becomes none. When I put a bus, it again shows as bus. So that is the beauty of publishing this as an MQTT topic. So that's how I'm basically using the combination of the Horn Sanjam SmartCam and Raspberry Pi to publish the inference feed to the MQTT topic. Now that is the first step. Then what actually happens is we want to control the bulb, right? So let's take a look at the code that is responsible for controlling the bulb. So the bulb that I'm using is a Philips Hue smart bulb, and Philips Hue smart bulb uses a protocol called Z-Wave, and there is a bridge that exposes the REST endpoint, and this is not available on the internet. You cannot control the Philips Hue bridge directly from the internet. So it is running on my LAN, and this is the IP address of the bridge. And I'm using a high-level library for Philips Hue called QHue. You can do a simple pip install QHue, and this loads this installs the Python library. So I'm using that. And then this is the bulb MQTT client. So I'm basically configuring this with the AWS IoT SDK. Everything remains the same, except that it has its own set of certificates. And then it expects the messages to come from a topic called bulb/color, whereas the camera is publishing to a topic which is camera/infer. So these two are completely different topics. Now, why do I want to do that? If I actually subscribe to camera/infer in the bulb, then I have to write a lot of business logic. For example, to change the color, when a new vehicle comes, and I don't want to hardwire that. I don't want to hard code what bulb color should be shown when a different vehicle supports. For example, today I'm supporting a bus and car. Tomorrow I want to train the model for a truck. Now, when I train the model, I don't want to come back and write another if condition that says if vehicle type is truck, then change the color of the bulb to yellow. Now, that is not the logic that I want to use within the bulb. The bulb should be simply able to change its color based on the input color. So I want to just send what is the color, but the logic responsible for sending what color the bulb should change is what is going to be defined in the Lambda function, because the Lambda function is going to very elegantly decouple my camera from the bulb. The camera doesn't know that it is talking to a bulb. The bulb doesn't know that it is being controlled by a camera. But in between the camera and bulb, we actually have a Lambda function that is responsible for just telling the bulb which color it should glow in. And this makes it very, very elegant. So, for this demo, I have hard-coded the color, but this can technically come from the Lambda function. So, I didn't want to make it too complicated, so I just kept this logic here. So now, what happens is, we have the camera feed coming to the cloud. You actually see that the sequence is increasing. This is fantastic. Now I need to apply the logic, and this logic is going to be written as a Lambda function. So let me show you that Lambda function. So I'm writing a very simple Python Lambda function called bulb color, and it has one entry point, the function handler, and there what it actually says is, if the object that is detected by the camera is car, which means if the MQTT topic has this message called object is car, then set the color to green. If it is bus, set the color to blue, and then publish it to a topic called bulb/color. And this bulb/color is the topic that our smart bulb is subscribed to. So whatever the Lambda function asks is going to be done by the bulb. It doesn't have a clue whether it is responding to an event raised by a bus or a truck or a car. It doesn't really know. That logic is handled and addressed by the Lambda function. And this is the power of Lambda. It is the business logic that connects multiple devices with very few lines of code. Truly serverless, truly event-driven. Now, what we'll do is we will deploy this as a Lambda function. So here I have gone ahead, I have included Greengrass SDK as the dependency, and I zip the whole directory. Now I will show you how it shows up in the Lambda console. So here is the AWS Lambda console, and here I have this function called Greengrass bulb color, and this Greengrass bulb color is currently is currently uploaded to the cloud. You can actually see the same code that I have shown you in my local machine, but currently in the Lambda. I cannot run it in the cloud. I cannot actually test it in the cloud because it runs in the context of Greengrass. So don't get tempted to try it in the cloud. Now what I'm going to do is the Lambda function is uploaded to AWS Lambda. So I come back to my Greengrass core, and here, once I access my group, which is MI2 demo, within that, you'll notice that there is something called lambdas. So now I'm going to click on add lambda, use existing lambda, and it shows up here. So now I'm going to bring in the Lambda function that is registered with AWS Lambda into my Greengrass, and I'll use this function called gg bulb color. And what this actually does is it's going to now create, of course it's already there, so it doesn't really change much. So now we have brought in the Lambda function into the Greengrass context, and after that I can actually edit the configuration. These are advanced settings. You shouldn't be fiddling with it unless you know what you're doing. But one thing that I want to highlight is the Lambda function is an on-demand function, which means this is going to be run only when a certain condition is met. Pretty similar to how you create the cloud-based Lambda. If you want to run like a daemon, you can always run it as the long-running function. So in our case, we are going to use it as an on-demand function, which means it only gets invoked when the MQTT topic gets published. But how do I tell Greengrass to invoke this Lambda function when the camera feed comes in? Exactly, that is the question that you have in mind. So that's where we have the subscriptions. So here we create a couple of subscriptions. The first subscription that we create is, the source is IoT Cloud, because the camera is publishing the feed to the cloud. You can actually see it coming here. It is publishing to the cloud. So the source is IoT Cloud. The target is Lambda. That means when this MQTT topic gets populated, and here we mentioned the MQTT topic as well. So when camera/infer gets populated, the topic filter, the messages will automatically start invoking the Greengrass function. So that is how we connect one dot, that is, or rather two dots, that is the camera with Lambda. Now, once that is done, we also need to define another subscription, and this subscription is to publish back to the bulb color. So then I'm going to do the reverse of it. So now that I'm getting the feed into the Lambda function, and the Lambda function will figure out what is the vehicle type and sets the color, and this needs to be published back to a topic which is bulb/color. So that's exactly what I do. So now the source becomes the Lambda, target becomes IoT cloud, because we want the messages to flow back and forth to the cloud. I can actually directly set this to the bulb, but I don't want to restrict it only to the offline. I want to extend it to the cloud, so I choose IoT cloud. But technically, I can pretty much target just the bulb, right? Because I want to show you the feed here in the cloud, I'm choosing the target as IoT cloud. And then what is the target topic? Well, it is bulb/color. That's it. Now I create the second subscription, which means Lambda will receive the input from camera infer and will write the output to bulb/color. Now, once this starts running, if I subscribe to this topic, for example, when I subscribe to this topic called bulb/color, now it's showing none. That's what we coded in our business logic. If there is no object, then show it as none. Now, guess what? If I actually place a car in front of the camera, and of course the bulb is glowing, that means there we go. So it figured out that the color is green because the business logic is applied, right? The logic, when it is car, the color should be green is applied, and it immediately gets published to bulb/color, and it gets picked up by our Raspberry Pi, responsible for controlling the bulb, and all the magic happens. So that is the beauty of using Lambda as the glue between two devices. And you can write a lot of things. For example, if I want to send out an SMS, I can use Twilio API within Lambda, and it sends me how much I'm charged because of the vehicle type passing through the toll gate. I can do a lot of things. So that is the advantage of using Lambda as the business logic between the devices. So to summarize, there is a camera which is publishing to the topic that gets picked up by the Lambda, and in Lambda we are not mentioning what is the topic. It is the power of subscriptions. So subscriptions connect camera to Lambda, and again the subscriptions connect the Lambda to the bulb, and we only tackle device specific logic in each of these device specific code that is running on a Raspberry Pi or very close to the device. But it is the Lambda that is responsible for this. And by the way, this Lambda doesn't run in the cloud. Obviously, it runs in the context of AWS Greengrass locally. So that's the demo that I wanted to show you. And once you have everything configured, what you can actually do is you can say deploy. So once you add the devices, then you create a Lambda, then you create the subscriptions. After that, all you got to do is deploy it. And when you deploy to the group, all the changes that you have done, for example, your subscription rules, your Lambda functions, everything gets pushed all the way to the edge. So this one click will apply the latest configuration to the entire group. So that is how Greengrass is architected. I really like the way Amazon designed Greengrass. Very well thought through, very lightweight compute based on Lambda, very declarative in the way you create the rules, and the device SDK has matured. It is now very efficient, very lightweight, very low footprint, and of course the ability to talk to local resources, which I didn't cover. So for example, if you want the Lambda to talk to a local file system, you can always provide the path, the location where you have the file system, and then Lambda will instantly gain access to that. So you can also configure some local resources. For example, on a Raspberry Pi running Greengrass, you want to talk to the camera, you will actually configure that as a device and give explicit access to your camera to the Lambda. And now Lambda can talk to your camera. So you can actually create local resources. And of course, there is also a concept called connectors, and this is very new. So connectors help you to declaratively bring in third-party services. For example, if the Lambda has to send an SMS via Twilio, you can add a Twilio connector. And this Twilio connector will be responsible for Twilio notification. So it is now responsible for automatically sending out the notifications to the target to the target phone. So you basically select the resource, and then you give the the phone number and the Twilio account ID. If you want to manage your credentials, you can also store them in what is called as AWS Secrets, which is again a new service. So without writing code, you can technically extend your Lambda to Twilio just by configuring these details. So you just get the Twilio authentication token, you embed that here, then you tell what is the number that needs to receive the notification, and you input your account SID, and boom, you can now enable Lambda to send out a Twilio notification because that resource is now configured. So that is the power of connectors. So all these form the Greengrass group. So that brings us to the end of this session. Now, I want to, like every time, I want to bring up a quick poll. So how relevant was the webinar content? So when you looked at the title, when I shared this with you, maybe in Twitter, Facebook, or LinkedIn, what did you expect and how much of that was met? And is the content relevant? Excellent. I appreciate if everyone participates in the poll. This is very important for me and our sponsors. So great, thank you. Finally, I have one poll that directly reflects upon my demo scenarios, my presentation skills, the whole experience of attending this webinar. Great, thank you so much, and I'm committed to bring you the best of the content, best of the emerging technologies in the upcoming sessions. So before I move to the questions, I don't have a lot of time. We are already at the top of the hour, but I want to announce, so a quick summary. So why you need Greengrass Core: low latency access, reduced bandwidth, offline availability, local ML inference. Those are the things that you get with any edge, specifically with Greengrass. I want to thank our sponsors, the Newstack, our media partner. This Friday, you will see an article going on the Newstack, and as soon as I upload the entire source code to GitHub, I'm going to upload the YouTube, update the YouTube video with the links. So stay tuned for that. If you're watching this on YouTube, look at the description below. You'll have a link to the Newstack article and also to the GitHub repo containing the source code for the entire demo scenario. So Foghorn, an edge computing company based in Bay Area, one of our sponsors, I want to thank them. Portworx, a leader in the container native storage, doing an amazing work with Kubernetes persistent, running persistent services and stateful services. They are also one of the sponsors, and I want to thank them. And announcing the next session on the infrastructure part. Today you have seen the intelligence part, and the infrastructure track has something exciting called Linkerd. So this quarter is all about service mesh. Last month I covered Istio and I got pretty good response. Thank you for that. Couple of weeks from now, on May 30th, I'm going to walk you through Linkerd, another popular service mesh, which is also a part of the CNCF Foundation, CNCF projects. So stay tuned for that, and you can always go to mi2.live and sign up. And now it's time for me to take a couple of questions. Can we use any other smart bulb? Absolutely. No, Philips Hue, I just find it very convenient because it is wireless, as in I don't need to keep that plugged in. I can move around. It's very portable. So I use what is called Philips Hue Go. It's a portable bulb, but you can use Lifex, you can use any other Siska, anything that works. What is the name of the smart camera? It's called Horn Sanjam. You can find it in my YouTube channel, and I'm going to do more and more demos and content around that. hornsanjam.ai. So that brings us to the end of this session. Thank you again for joining and encouraging me. So stay tuned for the upcoming announcements, and do sign up at mi2.live for the upcoming webinars. Thank you. Have a great week ahead.